Okay, so this is going to be a video on just the test, going over the solutions to the test, get that out of the way so I don't have to use class time to do that. So let's just jump in. Number one, so was e to the 2x cosine of 2x. This one was probably the one that took the most amount of paper to actually solve it. So this is an integration by parts, where the original problem pops up. So that's going to be sine of 2x over 2. So we have uv minus the integral of v du. Those 2's will cancel, so we're left with e to the 2x sine of 2x. And then we're going to integrate by parts again. So u is e to the 2x, dv is sine of 2x, du is 2e to the 2x, v is negative cosine of 2x over 2. So now we have u times v, so that's e to the 2x cosine of 2x over 2 negative minus the integral of v du. So that's going to be plus. 2's will cancel. E to the 2x cosine of 2x. And there's the original problem you see. So we have e to the 2x cosine of 2x is equal to e to the 2x sine of 2x over 2 minus plus e to the 2x cosine of 2x over 2 minus plus minus the integral of e to the 2x cosine of 2x. Bring this to the other side. So we have 2 of those. And I'll divide by 2. So the final answer would be 1/2 times this. Which makes that over 4 if you really want to be particular. So there you go. There's final answer, that one. Number 2. This one actually turned out to be one of the most missed ones. So this is a u sub start off with. U equals radical x. And du is 1 over 2 radical x dx. So 2 du is 1 over radical x dx. Okay, now the common error here, well, let me finish this and then I'll go back to the common error. So we end up with the natural log of u, 2 du, and the antiderivative of natural log, u natural log of u minus u, or 2 radical x natural log of radical x minus radical x. Okay, plus chips. The common wrong answer here was to let u equal natural log of radical x. And then everybody wanted to say that du was 1 over radical x. Okay? But that's not true because of the chain rule. The derivative of natural log of x is not 1 over radical x. It's 1 over radical x times 1 over 2 radical x because of the chain rule. So couldn't do it that way. At least there's other ways that you could have done this, but you couldn't do it that way and end up just integrating u du. That's the problem. Most people said, oh, du was 1 over radical x, which isn't true. Okay. A couple of people actually did end up integrating this by parts and got the correct answer also. Number 3. I think I can squeeze number 3 right here. This one also took up some space. Square root of x squared minus 9 over x cubed dx. So this is a trig sub, so we're going to say x equals 3 secant theta dx is 3 secant theta tangent theta. So I've got the square root of 9 secant squared theta minus 9 over 3 secant cubed. That 3 needs to get cubed. A lot of people forgot to do that, so that'll be 27 secant cubed theta, and then we'll substitute in what dx was. Dx was 3 secant theta tangent theta. So this ends up being 9 over 27 is how that simplifies, or 1/3 tangent squared theta over secant squared theta d theta. And if you simplify this, tangent squared is sine squared over cosine squared divided by secant squared, you end up basically just getting 1/3 sine squared theta d theta. So now you've got to integrate 1/3 sine squared theta, so that's going to be 1/3 times, antiderivative of sine squared is 1/2 times theta minus sine theta cosine theta. And then we'll go ahead and say that's 1/6. Theta is going to be the inverse secant of x over 3. And then sine theta cosine theta, so I'll go back up here and draw the triangle. X over 3 is secant. Oops, that's cosine. Which makes that x squared minus 9. So now sine of theta is square root of x squared minus 9 over x, and cosine theta is 3 over x. Okay, plus c. All right, so that was number 3. Number 4, we're skipping because I made a typo and didn't catch it. Very annoyed by that. So you all got a free point, or a free question, I should say. So let's go to number 5. So that's x plus 3 over x squared plus 9x plus 20. So you factor that. That's x plus 3 over x plus 5 times x plus 4. And then we'll go ahead and figure out a and b. So when I do this, a ends up being -2 over -1, or 2, and b ends up being -1 over 1, or -1. So this ends up being 2 natural log of x plus 5 minus natural log of x plus 4. Okay? Plus chips. Number 6. E to e squared of 1 over x natural log of x. So this is a u sub. U is the natural log of x. Du is 1 over x. I'm going to change the bounds. This ends up being 1 over u du, and I'm going to change the bounds. So when x is e, u is 1. And when x is e squared, u is 2. So now I've got integral of 1 over u du from 1 to 2. That's the natural log of u evaluated from 1 to 2, or the natural log of 2 minus the natural log of 1. Natural log of 1 is 0, so this ends up just being natural log of 2. If you didn't change the bounds, you end up getting the natural log of the natural log of e squared minus the natural log of e, which simplifies to that. All right, next one, number 7, is the other trig sub. Sort of forced you into knowing how to do a trig sub. and integrating sine squared or cosine squared. Square root of 9 minus x squared dx. So x is 3 sine theta. Dx is 3 cosine theta. D theta. So this is 9 minus 9 sine squared theta times 3 cosine theta. Or this ends up being 9 cosine squared theta when it's all said and done. So that's 9 halves, or well, let's do it this way, since that's 9 times 1/2 theta plus sine theta cosine theta. Now we'll go back and resubstitute. Theta is the inverse sine of x over 3. Sine theta is x over 3. And cosine of theta, when I go to draw the triangle, is the square root of 9 minus x squared over 3. And there you go. That's number 7. Number 8. Number 8 apparently was in the review problems that I gave you. Some kids told me that. 8 was a really easy problem if you did what we talk about, and that's look for simplification before you do the calculus. Because this ends up being x cubed over x plus x over x squared plus 1 over x, which ends up being x squared plus 1 over x. That should be a squared there, plus 1 over x squared, or x to the negative 2. And then you can just integrate this term by term. So that's x squared over 2 plus the natural log of x plus negative x to the negative 1 plus c. And then number 9. So we saw this. Number 9. I feel like we've done this problem before. So this is just an integration by parts. U is the natural log of x. dv is x cubed dx. Natural logs make great use. du is 1 over x. And v is x to the 4th over 4. So it's x to the 4th over 4, natural log of x, minus x to the 4th over 4 times 1 over x dx. So this ends up being x cubed over 4. Which ends up being x to the 4th over 16. Plus juice. Okay? And then number 10. Number 10 was pretty simple if you knew the rule that you're allowed to use, because I told you would be allowed to use this. Okay? This is a p integral. This is of the form 1 over t to the p, or 1 over x to the p. The p value is 3/2. And that's greater than 1, so this integral converges. The p rule is if p is greater than 1, the integral converges. If p is less than 1, or equal to 1, the integral diverges. So we didn't have to do any work for that, but you needed to justify your answer. You couldn't just tell me converged or diverged. That wasn't going to cut it, because you could have just guessed. Number 11, you did have to work out. And what's crazy about number 11 is, when I was putting this together, I thought I typed this problem originally, and then I changed it, and I thought I changed this upper bound to a 3, just to make it simpler, but I didn't. So technically speaking, we're going to do this as the limit as b goes to 3. This is undefined at 3, and 3 is between 2 and 5. So we'll do from 2 to b of 1 over x minus 3 squared dx plus the limit as b goes to 3 from the other side of b to 5 of 1 over x minus 3 squared dx. Okay, and truthfully, what's going to end up happening here is we only have to do this first one because they're going to end up both being, this one ends up being infinity. So the antiderivative of 1 over x minus 3 squared is negative 1 over x minus 3. Evaluate that from 2 to b. So that's the limit as b goes to 3 of negative 1 over b minus 3 minus negative 1 over 2 minus 3. And as b goes to 3, this denominator is approaching 0, which means the whole fraction is approaching infinity, or negative infinity in this case, because of that negative sign. So that's going to infinity, so this integral diverges. Okay? So that's the test. These last two problems were 5 apiece, and then all the rest of them were, wait. I got to go back and figure. I don't remember how I did that. I guess these last ones were 6 apiece. I think I can't remember. Yes, they were 6 apiece because they were 66 points total, but I made it out of 60. So that's that. Let me know if you have any questions, and we'll see you later.